Good afternoon. My name is Matt Klosterman, and I'm a freelance developer. I'm based out of the Dallas area. And I currently focus on making iOS applications. I started working on iOS apps in 2008 when the first iPhone SDK came out. And over the past few years, I've worked on apps for companies like AccuWeather, American Airlines, and Disney. What I want to talk to you about today is about making apps that know. Specifically, we're going to talk about iBeacons and how they're going to allow you to make apps that are smarter. These could be iOS apps, Android apps, apps that are developed using native technologies, apps with HTML5 technologies that are inside of a native app wrapper. It doesn't really matter for what we're discussing. What matters is the app will know something interesting about the user and or their surroundings at a certain point in time. In other words, we're going to talk about apps that improve situational awareness. For an example of what I'm talking about, I want to start by taking you back in time 10 years. In 2004, I worked for a small company called Weather Data, and they eventually became part of AccuWeather. And this company had a focus on developing and delivering real-time weather information in innovative ways. And the project I worked on had two components. The first was this Windows mobile application that you see here. It ran on devices that had a GPS receiver that also had a cellular data connection. And since this was 2004, there were no iPhones, there were no Android devices. The first version of this app ran on a device like this. I'm not sure if anyone remembers these things, but this was an iPad Pocket PC from Compaq. And that black thing on it is a sleeve that held two PC MCIA cards. This one had a GPS card and a cellular data card. So with that additional hardware, what exactly did this app know? First, it knew about the user's location, and that was kind of novel at the time. There weren't a whole lot of apps that were combining geolocation information into a user experience. And second, it knew about the weather around the user at that exact point in time. It took the location that it got from the GPS receiver, and it sent it up to the server, and it got radar, weather warnings, and lightning strike information that was specific to that particular user. It was a great example of an app that increased the user's situational awareness. Now, this was part of a bigger solution, and the other part of this solution was an application that ran on a computer inside of a TV station, and it could be displayed on air. That was the part of the system I worked on. And the idea was that TV stations could send their reporters or storm chasers out during severe weather events, like tornadoes, windstorms, hailstorms, snowstorms, etc. And by doing this, the app that I worked on inside the TV station was able to know two key things. First, it could know the accurate location of everyone that was reporting on the event at that point in time, and it could share this information in the broadcast to the viewers. This allowed for an improved experience for the viewers at home. Previously, what would happen is TV stations would send tornado chasers out, they'd call in, they'd say, I see a tornado 3 miles northeast of me, I'm at 384th Street and Random Road, and then the TV meteorologist would be quickly fumbling with the computer trying to find where that was to give the viewer context. With this solution, what the viewer experienced instead was the person called in, they said what they were seeing, and the TV meteorologist could zoom in exactly on that reporter. So what they said that they saw a tornado 3 miles northeast of them, the viewer saw immediately where that was in relation to the storm, and it made more sense to them. Second, the app in the TV studio was able to gain knowledge from those storm chasers. Using an interface like this on a mobile device, a storm chaser could file that same report that they saw a tornado 3 miles northeast of them. They could also file hail reports, wind reports, snow depths, ice depths. And when they did that, the system inside the TV station would receive it. And with that knowledge, the TV app would plot a dot on the map showing that tornado 3 miles northeast of the last known GPS location for that reporter. The system gained knowledge about the storms, and it gained knowledge about how those storms were evolving over time. This was an entirely new way for people to see a storm unfold on TV. And the result was a system that was adopted in almost all of the largest TV markets in the country within just a few months. These apps knew things, and with that knowledge, they were able to increase the situational awareness of many different people. This created value, and it led to great sales for the product. So what made it possible for this small company to create such a product very quickly? How did they beat all the much larger players in the TV weather business to using mobile devices as tools to improve a viewer's experience? It was possible for them because the barriers to entry for certain technologies started to disappear, and it was resulting in a much leveler playing field. One barrier that came down is the technology to know where a mobile device was using GPS became cheap, and it was widely available. Second, the technology to connect these mobile devices to the internet reasonably reliably and at reasonably fast speeds was also becoming readily available. This company could now build products using these technologies with only a small investment, and at the same time, the software on the systems was maturing to the point that me, as a developer, all I had to worry about was making the app do useful things. I didn't have to worry about interfacing with the hardware. And that project was a lot of fun, and it opened my eyes to how exciting that mobile technology was going to become. And it's a big reason why I jumped headfirst into doing iPhone development in 2008. And now we're seeing another shift in technology. And I want to tell you about what's changing, why I'm excited about it, and hopefully give you some ideas for how you might use this new technology that's becoming more available. So what's changing? Well, in 2004, a large part of the value of the system we created was the general knowledge of where approximately that user was at. In 2014, devices still have that ability, and they're getting better at it all the time. They're learning how to detect if users move in and out of regions efficiently, and even learning where you're at inside of buildings. And perhaps more interestingly, these same technologies are allowing the user's device to get a sense for what physical, tangible objects are around a user at any point in time. With that weather system, we had an app that just enabled the user to get information and to send information back to the server. Today, with where devices are maturing to, it's becoming much easier for apps to take knowledge about what the surroundings and make better decisions for the user and make things easier for them. They're to be able to do this through sensors and other technologies. Sensors like cameras, microphones, gyroscopes, and more. And over the last few years, you've already seen apps that are evolving to take advantage of these. Things like augmented reality applications that combine compasses, gyroscopes, and cameras to blend real-world objects in with machine-generated information on the same screen. Something like what Jeff did in his keynote this morning that was really, really neat. Or they can use these sensors to do subtle tweaks to software we already use every day, like using the gyroscope data to help us guide our device while we're taking a panoramic picture. Or apps like Google Image Search that use your camera to visually identify things that you would have no idea how to put into words and ask about. These are really neat uses of technology we have at our disposal today, but there's a problem. For an app to see your physical surroundings, it has to see your physical surroundings, which means you end up holding the device in front of you like this. And that works well in some situations. When I first moved to Dallas and I saw Reunion Tower for the first time, I didn't know what it was. I just saw it and it looked cool. And I was able to pull out the Google Image Search, take a picture of it, and find out that was Reunion Tower and see all the details about it. That was neat, but I wouldn't want to do that all the time. I wouldn't want to hold my phone out in front of me everywhere I go. It's pretty awkward if you had to do that. And maybe for those situations, or to make this more widespread, we need apps that can sense their surroundings better than what they can with just cameras, and so the user doesn't have to babysit them. And if the problem is that apps that see require users to keep their device visible and pointed in a certain direction, what if apps could hear instead? We've already seen apps that hear things and do interesting things. Things like Shazam, where you record a bit of sound and it tells you what you're listening to. Or on a modern Android device or an iOS device starting with iOS 8, how you can say, "Okay, Google," or "Hey, Siri," and it's a clue to the device to wake up and take instruction from you. But what if we expand the idea of an app hearing beyond what we can hear as humans? Maybe you've used Shopkick or you've heard about this app. It's been around for a few years now. And the basic premise is that you go and shop in physical stores, and you get rewarded for doing so. And part of their reward system is they reward you when you check into the store, when you walk into the store. Now, since they're rewarding you, they want to know that you're actually in the store. And so to validate that, they put these specialized devices into stores, and they partner with stores, and they deployed these things. And what they do is they emit a sound that your device's microphone can hear, but your ear cannot. And that's interesting, because here we have an app that's now reacting to audible clues. It doesn't need the user to hold it in a certain direction or point it in a particular way. But there's still two problems. First, people aren't really keen on having their device recording audio all the time. So it's still kind of a start and stop manual intervention type process. And second, they still had to use a really specialized device. There wasn't some general purpose device they could use and buy and take advantage of. And that's where iBeacons come in. What makes iBeacons interesting is how they solve those last two problems. In simple terms, an iBeacon is a Bluetooth low-energy device, and it broadcasts unique identifiers at a regular interval. For now, you can think of it as kind of like the SSID of a wireless network. Now, being able to hear these iBeacons is a capability that's built into almost any iOS device that's in use today. And most modern Android devices can also hear them now. The language that iBeacons speak is becoming ubiquitous. iBeacons are simple to write software around. All the specifics about the iBeacon specification and how the radio signals work is abstracted out of the way for you. You just have to make the applications. And these devices are really cheap. Cheap hardware, easy to develop for, ubiquitous general-purpose solution to a previously very specialized problem. It sounds to me a lot like what was happening with GPS and cellular-enabled devices 10 years ago. And that's why I'm excited about iBeacons. The barriers to entry are disappearing. You can focus on making apps instead of dealing with esoteric hardware. But that doesn't really matter if what we can build isn't actually useful. So what exactly are iBeacons? Are they relevant to you? And can you make them useful for your users? Next, we're going to go more in depth on what iBeacons really are and what they do. We'll go over how iBeacons may be relevant to you regardless of which vertical the company you work for is in. And finally, we'll talk about technologies like Passbook and how they fit into all this. But before we get into that, let's look at some iBeacons and how much they cost. This is an Estimote. It's $35. It's battery operated. And it's kind of been designed to blend into whatever surrounding you put it in. This is also an iBeacon, the little black quarter-sized device. It's made by a company called Stick and Find, and it's less than $25. This is an iBeacon, that little black nub on the side of the computer that looks like what you get with a USB receiver, the USB receiver you get with some wireless keyboard and mice. It's made by Two Canoes Software. They charge less than $40 for theirs. Pebbles are now iBeacons. They use the iBeacon specification to let the companion app know when the app or the device that the app is on is or is not near the watch. Same thing with this automatic car sensor. It acts as an iBeacon to give a clue to the app that it's either near or not near your car. Even your users' iOS devices can act as iBeacons. Android devices will also be able to act as iBeacons, starting with Android L this fall. And since iBeacons are based on commodity Bluetooth technology, we're seeing them pop up in lots more different packaging. The technology's cheap, and it's very small, so you can put it in almost any plastic housing you could think of. And some of the vendors I've talked to say that they're able to do iBeacons for less than $5 a piece in quantity. So exactly how do these things work? Let's talk about how they work a little bit more before we talk about how you would use them. As I mentioned, they're Bluetooth low-energy devices. And part of that Bluetooth low-energy specification is an advertising packet. And like a Wi-Fi broadcast signal, all Bluetooth low-energy devices send these advertising packets and say, hey, look at me, I'm over here, and this is what I am. They say, I'm a Fitbit, I'm a Pebble, I'm an automatic car sensor, that type of thing. Well, Apple decided to take a small part of the bytes allowed for manufacturer-specific data in these advertising packets and encode several identifiers. First, a 16-byte universally unique identifier. Second, a 2-byte major number. And finally, a 2-byte minor number. That's great, but what does that mean? What can you do with these? Well, it means that the device was just telling you over there, telling you what it is, can now also tell you who it is and what it's for. This is exactly what we talked about wanting our devices to be able to hear. Some standard ubiquitous language of knowing what devices are around me so I can get a sense of what my surroundings are. So let's talk about these identifiers a little bit more. First, the unique identifier. You want to consider this as kind of one per company or one per very broad use case. And the reason why is that the way core location works on iOS is that you can only ask to care about 20 of these per application at one time. So you don't want to go and have 200 iBeacons with all different unique identifiers because then your app isn't going to be able to recognize all of them. On Android, however, you don't have any such limitation. Now, the major number, it's a 2-byte value, and it gives you about 65,000 unique values to work with. You can assign these in any way that makes sense for your application. The minor number is another 2-byte value, and it works the same way. Another 65,000 unique values to work with. You can assign it in whatever way makes sense. When you combine the major and minor number together, you have about 4 billion different possibilities of identifying physical areas or objects around your users. Now, the typical range of most iBeacons is going to be about 50 feet or less. In most places you deploy them, is either going to be confined spaces indoors, or if they're outdoors, you're going to have some sort of finite bounds usually. So within those constraints, 4 billion is a really big number. Now, inside that advertising data, there's not just identifiers. There's also this value called a transmission power value. What is that? Why does it matter? Well, what it represents is when you deploy an iBeacon, part of the deployment process is you're going to hold up your device and you're going to get an RSSI value from this device when you deploy it. You're going to hold the device a certain length away. And RSSI stands for Received Signal Strength Indication. And I'll talk about how you deploy an iBeacon so this makes a little bit more sense. Let's say I want to put an iBeacon in this room. We'll pretend the most logical place for the app I'm doing is right here on this podium. I'm going to grab my iBeacon and put it in a place that is relatively inconspicuous, but still has good radio frequency characteristics. Maybe I'll put it right here. Then what I'm going to do is I'm going to take out an iOS or Android device and run an app that's made by the company that manufactured the beacon. I'm going to enter in values for whatever identifiers that I want for my application for this beacon. And then I'm also going to hold my device about 1 meter away from that iBeacon. And I'm going to see what that RSSI value is when I hold it at that distance. I'm going to record that value. I'm going to put it into the configuration for that beacon. I'm going to set a password on it so someone else can't come along and reconfigure my beacon. I'm going to save it. And when I do that, the iBeacon is going to start broadcasting with those settings. And each broadcast that it sends out at this regular interval is going to include that transmission power value. Why did we do that? The reason is we now have a reference value of what the signal strength was at a certain distance when we deployed it. It's a reference point. Software up the chain from our app can take that reference point and compare it to whatever signal strength is at any given moment. And that's interesting because that software has the value from now and the value from before. What do you think it can do with it? That we calibrated the value at a certain distance should be a clue. The OS or iBeacon library you are using is going to take those two values and then estimate the distance your device is from that beacon at any point in time. How it does this isn't really important for this discussion, but if you want to know more, looking up this equation is a good place to start. What matters for now, what we're talking about, is really two things. We're able to get a rough idea of the distance our device is from a specific iBeacon. And our confidence in that accuracy is going to go down the further and further we get away from the beacon. I'm not going to go into that either. If you want to know more about that, find me in the halls afterwards. In iOS, this concept of calculating this distance is used for ranging. And it takes this distance estimate, and it's going to break it into 4 categories. It's going to tell you, is your device immediate to the beacon? Are they right next to each other? Are they near? Are they very close together? Are they far? Are they not close at all? Or unknown? It couldn't do anything with the data. And it's also going to give you access to that raw estimated distance measurement that it came up with. And it's important to note that this is truly only an estimate, and it can and will vary significantly. And as I alluded to, it becomes more and more true that it's going to vary the farther and farther away you get from the beacon. So that's what iBeacons actually are. They're Bluetooth low-energy devices. They're cheap. They provide 3 identifiers that should be sufficient for almost any use case you can think of, and they're designed to give you a rough idea of the distance of a device from a beacon. So can you actually build something useful with these? I think you can, and I'm going to show you a few examples of what's possible and what people are doing already. First, let's talk about what I think you shouldn't do. One of the first uses of iBeacons that companies have tried, and seems to be the first one that always comes up, is to generate these location-based notifications like you're walking through a store, and every few minutes you walk by something new and you get an alert saying, hey, there's a sale on this, or hey, here's an offer. And I don't think, as is, that approach is going to be very successful. It reminds me a lot of barkers on a carnival midway who are just standing there and they're yelling, trying to get your attention. Apps that do this probably are not doing a good job of improving your situational awareness. In fact, they're probably hurting it. They take you out of what you're doing. And if you see enough of these, you're going to start feeling like it's just a hassle, and you're going to turn off the notifications or location services on your device altogether. Your device isn't helping you, it's distracting you. So please don't start just blindly sending alerts to users as soon as they come near a beacon. Apps that do this are completely missing the point, I think. The real point is technologies like iBeacon allow you to create apps that are situationally aware instead of apps that just improve the user's own situational awareness. You can now build apps that feel smarter to the user because the app knows what's around the user at that point in time. It's, for lack of a better word, seeing the same things the user's seeing. Instead of knowing that the user's at the science museum, the app knows that it's at the user's at the weather exhibit in the science museum. And it could also possibly know which direction you're facing within the weather exhibit. iBeacons give your apps clues about where the user is really at and what they really care about at that point in time. And those clues are the difference between your app doing work for your users and your users having to do all the work for themselves. And that's powerful because the whole goal is to create these experiences that feel natural to the user, experiences that make them feel like the device is making things easier for them, and not experiences like this one. You don't want your user to be thinking about how they are using your app. You don't want them to think about how heavy the iPad is when they've been holding it up for an hour walking through the museum. You just want them to use it, in your app, and be able to trust that it's going to help them in whatever it is that they're doing. So what does it take to make good use of iBeacons, and what are some good examples? Well, here's kind of a better example. Launch Center Pro is an app by a company called Contrast for iOS. And basically, it's an app that allows your iOS device to, you set shortcuts in Launch Center Pro for different apps on your devices, things you want to do quickly. And then when you trigger that action, it takes you directly to that part in the other application. Like, for instance, it takes the last photo you created and it sends it as an email, just as an example. This app, like the common retail store example, it generates a notification when you come near a beacon. This is a new feature they added recently. And the way they did it is, unlike that example where you're just walking through the store and blindly getting ads, they also asked you when you created this trigger, like, what do you care about? When do you really want me to interrupt you? And it takes that information, and then it's not going to interrupt you in times that you don't care about knowing or performing an action. The app knows your preferences, and it makes intelligent decisions about when to interrupt you. It isn't that beacon-based notifications are bad. It's just that naive beacon-based notifications are bad. If you're going to prompt the user, you should really make sure that the user is going to care about what you're displaying for them. Because if you're interrupting them, they want it to be for a good reason. So let's go back to the museum example and talk about another use of iBeacon that's interesting. There are museums that are starting to modify their apps or their guided tours that they have from being audio-based tours or tours where you go and you hold up an iPad and you scan exhibits or QR codes. And they're starting to use iBeacons to kind of guide you through the museum instead. Now, a lot of these implementations are doing the same thing of every time you get near an exhibit, it just pops up an alert. And we've already established that's bad. Maybe the user doesn't want to stare at a screen at the museum like this, and maybe they also don't want their phone to be buzzing every time they walk around and looking to see if they need to care about something. I don't know about you, that's not what I want to do at a museum. All that they have done in these solutions is they've taken the information they heard from the beacons and they're just passing it directly to the user. They're not putting any smarts around it. So what if, instead of jumping into the user's face every time it gets this information, instead, the way they handle knowing about the user's surroundings is, I'm walking through the museum. I'm seeing exhibits that interest me. And when I want to know more, I pull out the app. When I pull out the app, it knows which exhibit I'm closest to, and it automatically navigates to the content about that exhibit. So I don't even have to think about it. I don't have to go find which exhibit I'm at. It just knows. Or what if the app for a museum could tell me that there's guides nearby and roughly how far away they were. So if I had questions about something, I could get help and know if there are people nearby to help me. These are the types of uses that have me really excited about iBeacons. They take iBeacons for what they are, clues about the user's surroundings, and they combine it with knowledge that we already have about the user to provide an experience that just feels right. So we talked about iBeacons as a clue about what surrounds your user, and we talked about how you can use ranging to get approximate distances to beacons. What else could we possibly do? Remember, we said that the user's mobile device could also act as an iBeacon, and I alluded to this a minute ago. What if you treat a person like a museum guide as a beacon to make it easier to ask for help? Or what if me, as the patron, I use the app and I say I need help, and the app begins acting like a beacon, and then somebody who works for the museum who has an app knows that somebody nearby needs help and how far away they are. And potentially, depending on which market you're in, you could do things like you could have the picture of the user and know, here's who I need to help, there's the person, and walk directly up to them and ask how you can help. Or what if we think of arbitrary objects as beacons? There was a project earlier this year that was occurred at a hackathon put on by Emirates Airline. And what they did is they put beacons onto checked baggage so that the experience as a traveler is when you went to the baggage carousel to get your bag, you didn't just stand there looking at every single bag waiting for yours. You knew when yours came close to you and you knew how far away it was. Now, I promised this talk would be about iBeacons and also Passbook, and how those two are the real augmented reality to me. I hope you're seeing how beacons can assist apps in getting some ideas that we've seen in augmented reality concepts and start taking them more mainstream so they get wider use. But I haven't even mentioned the Passbook part of this yet. And part of that is there's a lot more than just iOS developers here today. And so instead of just talking about Passbook, I want to talk about technologies like it. And so conceptually, I'm talking about any technology that can give you easy, glanceable access to information, like on your home screen or your lock screen, or like as a widget on an Android home screen, that type of thing. Now, I also want to consider notifications. These could be notifications for Passbook. They could be push notifications for your app on either iOS or Android, but notifications that not only tell you about something's happening, but ask you a question. Notifications that say, here's what happened, what do you want to do next? And give you the option to do A or B. And with those concepts, I want to walk through a kind of a contrived example. Let's say we're going to go on a cruise. And maybe a few days before I go on my cruise, the cruise line pushes a notification to my app, to their app that's on my device, to remind me of my trip. Just make sure I have everything in line for my trip. Then, a few days later, when I arrive at port to go on my cruise, what if my phone hears an iBeacon that gives it a clue that I'm at the port, but I'm not yet on the boat yet? And when it hears that clue, it surfaces my Passbook pass or some information on my Android lock screen or home screen so that I can very quickly share any information I need to expedite the boarding process. And after I'm on board, as I'm walking towards my cabin door, I receive a notification that's generated from the app, and it's saying, would you like to unlock your door? I tell what I do, and the door unlocks as I approach it. There are hotels right now that are trialing that exact concept. And after relaxing in my cabin for a while, I receive a notification for my dinner reservation that asks if I'd like directions to the restaurant. I say, yes, I do. Give me directions. It opens the app, takes me directly to the map, and starts guiding me through the ship to where I need to be. After dinner, my Passbook pass is going to update. The reason why is I opted for some alcoholic beverages that weren't included in what I paid for already. And my Passbook pass is updates to give me this glanceable information of, here's the tab that I've generated beyond what I've paid for. Now, the cruise line might not actually use that, but this is a contrived example, so we'll move on. The next day, while the ship is docked at port, and I'm not on board the ship, I open the app. The app senses that I'm in the middle of my trip, but that I'm not near any of the beacons on the ship. And so the app knows that maybe what it needs to do is prioritize information about excursions or shopping destinations or directions back to the ship to me inside the app. These are the types of experiences that can be created by apps when it knows about the user's surroundings. And iBeacons are a great tool for that. These are the types of apps that know, and these are the types of apps that feel right to users. And these are the things that are becoming really easy for you and me to do. We don't have to go and figure out how to do all of this work with the radio frequency behaviors of Bluetooth and all that stuff. We just deal with simple APIs. So I hope what I've done is give you some good ideas of what iBeacons are and give you a starting point for what you could do with them, no matter what industry you're working in. That's all I have for you today, and I'd like to thank you for your time. And I think I have time for some questions, if you have any.
So all of your examples were kind of in one or two dimensional space. Your application to a beacon. How good are these tools at finding location in three-dimensional space?
So the answer is not great. So an iBeacon's not a great tool for, like, say, triangulating a user's position and nailing down where they are. You can do it. It's not going to be very precise. To get it precise enough, you're going to have a lot of iBeacons around. There's other technologies that Apple and Google have that do indoor positioning that are much more precise. The problem with those is that they're not to the point that they're general purpose for you and me to use. So the result is you see people doing like wayfinding using iBeacons, and what you get is basically a zone that they're in instead of here's an exact pathway that they are taking within a building or ship or whatever.
So iBeacons are based on an open standard of Bluetooth Low Energy, right? So there's different manufacturers that are creating these devices. Each seem to have SDKs that are available. Is it possible to create an app that's kind of generic that interoperates with any of these manufacture beacons, or do you really have to have the SDK that pertains to that particular manufacturer device?
So it's not really an open standard. It's the way iBeacon has come about is Apple introduced it with iOS 7 in 2013, and it's basically the way Apple's doing it, and so everyone else is kind of following along. I mean, there's nothing, they don't control Bluetooth, so it's very easy for all the other companies to just see how they've encoded this data and then do the same thing, encoding the data or decoding the data. What really that means is since Apple is supporting it in this way, everyone else is following them because this is part of the reason if you're not an Apple fan, you're not an Apple fan, is because they're not going to go and use someone else's technology. They're going to do it their way. So iBeacon kind of has a leg up just because you've got 300 million iOS devices that speak this language that wouldn't otherwise. And so you have all these manufacturers making these iBeacons, and kind of the lowest common denominator is iBeacon. And so these SDKs you're talking about, they allow these hardware manufacturers to kind of differentiate beyond that. And so, like, for example, Stick and Find has one. They were doing kind of beacon-based stuff even before Apple did iBeacons. And so they have a technology called SBeacon. And so if you wanted to, you can integrate their SDK into your app, and you can do things that are much more advanced, might not be the right word, but you can have much more options available to you than what just iBeacons provide. What really iBeacons provide is the ability to integrate with the OS, so that your app doesn't always have to be running. The OS can do the heavy lifting and can prompt your app. Does that help? Does that answer your question at all? Or
I think so. I'm doing a proof of concept with one from a company called Swirl, and they have kind of two different modes of supporting their own type of beacons, and they also support iBeacons, and I haven't really discovered what the difference is yet.
yeah, so like I said, iBeacon, think of that as basically it just tells you whether something's near, and it gives you that idea of the distance. But then that's not the only thing that you can do with these radio signals. So these companies are differentiating and adding on new features based on what they come up with ideas of measuring these signals and adding value. And so that's why they produce their own SDKs. I hope that helps.
I just don't know if you know, but in terms of security and using things like uniquely identifying iBeacon,
Yeah.
Is there any like TLS or mutual TLS or some sort of certificate
No.
so that you truly know that it is a unique iBeacon?
The answer is no. And there's iBeacon vendors out there that are trying to come up with ways to solve that. A lot of companies see that as a concern for some of their use cases. And like I said, was telling in answering his question, iBeacon's just a really simple kind of, hey, do you hear me and how far away am I type thing. And that's all there is. There's no two-way communication at all. It's sending there broadcasting. And there's nothing keeping me from taking an Android device and hearing all the beacons that are around me and then configuring other ones to act just like it. So that's why some companies are producing their own SDKs that kind of have follow-on protocols above that and do encryption to handle use cases like what you're talking about.
Would there be a potential application in like transit, like putting them on buses so you would know like the particular bus you want to be in and then put that with a transit like routing app?
Yeah, that's, I think so. Like, it seems like a good use of the region monitoring idea of you're standing at the bus station and there's a beacon that's tacked on the side of the bus, and then when it gets close enough, it lets you know that that's your particular bus. The range is a little bit of an issue since most of them are 50 feet. There's some vendors out there that are making kind of specialized ones that they say can go up to half a kilometer, which those would be probably more interesting for that use case that you're talking about. I think that's probably the time I have, it sounds like. So thank you. I appreciate it. And if you have any more questions, find me in the hall. Thank you.